This shows you master activity and PhD schools. We have several specialization, or anyway, in the ICT context. We have, for example, sound engineering, advanced system for satellite communication navigation, photovoltaic engineering. It is a fundamental activity for our department, which has produced several spin-off small companies. As regards PhD school, we have divided our PhD school among four main activities. The first one about electronic system, second one telecommunication and internet, the third one about sensing and knowledge system, and the last one, but not least, obviously, technology, system and technology for space. The end, we have summarized the main research activity in which our department is involved. Some of them, I told you, are related to ICT, and other one mainly in electronic technology. Obviously, there are hybrid activity. For example, for space technology, obviously, we have to express competence both in telecommunication and ICT technology and in hardware electronics technology. This is an example, but several of these teams obviously are multidisciplinary. So this is the strength of our department. I thank you very much, and I show you the main contacts for our university and our department. Thank you, gentlemen. Okay.
Okay.
Any questions?
For presentation. Do we have any questions?
Thank you, Professor, for the presentation. Any questions?
Very impressive.
Yeah, thank you, Professor, for the information. So we would like to collaborate with your university in the area of the green technologies, signals and sensors, automation. These are the major areas we would like to interact. And if the people who are working on the space technology, we also would like to interact for the development of the sensors for the space area also.
Okay. Sorry, but the audio is not good. It's not good.
Right, please. Right, please. Can you write your question?
Yes, sir.
Collaboration in the area of sensors, green technology, automation.
It's a comment. We
Collaborations in the area of green technologies, sensors, automation, and space technology.
It is possible. We'll keep in touch for
Yeah, point of contact
you can write so we can discuss about non so se okay,
Okay.
you can write
Allora, senti, vai tu, dai. Now we have a Professor Mulone is presenting the department of... Sorry. Professor Mulone will present the Department of Industrial Engineering. That is the second department involved in our cooperation. Okay? Ok? Allora, non ci hanno risposto. La presentazione la vedo? Sì. Sì, no. Chi c'è? Quale questa sana? Ci prendiamo la Siviglia, giusto? Partita? Ok. Quanto risponde a questo? È la struttura locale. No, era pure spesso no. Cosa è? Io sono abbastanza non so miata da scrivere. Alle 10 meno un po'. Di noi ci siete voi? Questi stanno fino a stasera. Stasera, ma loro fanno seguire l'agenda. Va bene, così.
Okay, so good morning or good afternoon, everyone. And I'm Professor Mulone. I'm a professor at the Department of Industrial Engineering, which is the other department, like my colleague Giancarlo Gardarilli said. And the department we are talking about hosts 50 professors coming from a number of different sectors. There are 15. And we have almost 20 administrative and technical staff people. And quite, a high surface of labs available, so more than 1,600 square meters, and a number of international collaborations in the fields of teaching, of course, so exchanging students with European and American universities, primarily. And also in the field of research, of course. So what I want to provide you with is a brief and very general overview of what we have at our disposal. Can you hear me, however? Non sapevo mai.
Avanti?
No, dicevo, non sapevo mai se mi ascolta. Okay, so this This is the teaching organization we have. We're talking about the bachelor courses we have. The Italian language is held on purpose because the mechanical engineering and energy engineering, so Ingegneria Meccanica and Ingegneria Energetica, are taught in Italian currently. But we have, and this is our boundary of internationalization, a bachelor course which is taught entirely in English. Its name is Engineering Sciences. Actually, this course has been founded, I think, 8 years ago, and it has a bunch of sub-curricula that are mechanical and energy engineering, electrical engineering, and internet and communication engineering. Then we have, of course, the counterpart at a master's level of the mechanical engineering, taught in Italian, Ingegneria Meccanica. So it's a 2-year course, so it's equivalent to a master course with thesis and with 120 European credits. And for energy engineering, it's mostly the same. What we recently implemented is a new course at the master level, entirely taught in English. The course is named Mechatronics, and actually is the result of a collaboration between our department and the electronics department, which you have seen just before my presentation. So this is a new kid. Let's say we are growing up together. And this course has just been started right now, and we will try to mix the skills we can teach to the students, so primarily in the mechanical and energy fields, along with the skills our colleagues in the electronics field have. So we think both the engineering sciences and mechatronics are a good way to exchange students with you guys. So whenever you want to send some of your students, we can talk about that, of course. Then there is another relatively new course, which is on nanotechnology. Instead, is the last one. And this one instead is an Erasmus Plus course that is shared with other universities, and it's also entirely taught in English. So it's more on the materials, let's say. Okay. Okay, let me briefly recap the characteristics of our research and development activities. Sorry, here a word just left a phrase in Italian, but this is materials and production processes. So we have two main souls in the department. One is the energy related activities, and this is primarily done in the fields, in the subfields of conversion processes. So whatever is needed, both at fossil, traditional, and relatively new technologies like or storage, hydroelectric, or compressed air, CO2 capture, and so forth. We have renewables and microgrid, also linked to power electronics, and my colleague Professor Bifaretti will show you some of his activities today in power electronics. Also, perhaps to be coherent with what you presented in your earlier presentations today. And another relatively successful branch, which is hybrid and electric vehicles, and which is the counterpart of our activities in the renewable sector. And of course, we have a traditional engine development program. I'll probably talk to you about it later. Okay. On the other hand, we have our groups quite active in the metallurgy and manufacturing technologies fields, and on the materials, including nanomaterials, nanotechnologies, and also we are pretty successful in the development of diamond-based sensors. There are two subtopics which are a little out of the bunch: the laser technologies and biofluid dynamics. But also there are two which are considered, as a merge of the two souls of energy and materials, which are fusion energy. We work quite a bit in the European programs for the development of fusion reactors, and management engineering, that is, of course, kind of supervising the things. Okay, this is our lab, so I don't want to go into the details because we need to save time. Of course, you can feel free to share this presentation with whatever you like. And these are some images, the fields. So we are active in a lot of things, but so these are just photos, and then we'll take our chance to in the later presentations to show you, more accurate and detailed presentation of our results. Actually, okay. So that was it from my side. Thanks very much, and I'll talk to you later.
Okay. Do you have any question? If possible, the next. Okay. Sorry.
Yes.
If possible, the next should be Professor
Hello.
Piparetti.
If I may ask a question, is it possible?
Sorry. Please repeat. Repeat.
Any questions for the talk? Diamond-based centers.
We would like to invite the professors of your department to be visiting professors at our university in the specialty of mechatronics. We are inviting the professors of your department to our department. Visiting professors for mechatronics.
Okay, thank you. Please let us have some the activities that are in, and we can for sure availability of some of our Thank you. Okay, regarding the okay, so regarding the electric and hybrid vehicles, we are working with right now with an Italian company which is named Iveco, and we are developing. So this is a research that I do myself, and is on the development of plug-in hybrid buses for public transport. And the primary objective is to downsize the internal combustion engine and save costs, have less emissions, and have an extended time of operation of the buses in the traffic restricted areas with zero emission. So the purpose is design of the vehicles, and we also have a vehicle here in Tor Vergata which have developed, but what we do research on is the strategies. So the strategies on a supervisor ECU that is aimed at maximizing the efficiency of the vehicle, looking also at the issues of cost and the equipment that is involved. So this is more or less the projects on hybrid vehicles we are doing right now.
Thank you very much. And we would like to invite you as a visiting professor for our department of mechatronics also. And it would be great if we and VIT University could develop a grant project for Horizon 2020 program. We already made a sketch and would like to negotiate the details, and maybe you would like to be a coordinator of the project. Thank you very much. Right now we don't have any other questions. Maybe.
So, if possible, I want to give the possibility to Professor Bifaretti to start now the presentation because he has to go to the lecture. Yeah, hello, good afternoon. Just a second, we load the presentation probably. Vai avanti. Okay, we are ready. Hello, good afternoon to everyone. I'm Professor Bifaretti. I'm an assistant professor of power electronics and electrical drives. So the main research area of mine is power electronics at the University of Rome, Tor Vergata. But last year we have found, together with the University of Roma Center for Power Electronics and Drives, that today is counting on 11 members from 4 different research centers, and also other institutions are applying for joining this research center. So this was made mainly to join our competence, our skills together, and make a stronger cooperation also with other institutions abroad. Okay. Basically, as you know, the power electronics is an enabled technology for many of actual industrial applications in transportation, for renewable energy production, for the future electricity grid. And these applications are requiring and will require in future more effort on power electronic converters because they will require more complex structures such as multi-level converters and modular architectures in order to improve the fault tolerance capabilities and improve also the power quality. So in this framework, our main research areas are on divided in 3 main categories. We divide in Internet of Energy, mobility, and Industry 4.0. For what concerns the Internet of Energy, we are working on for many years on solid-state transformers, on converter for renewable energy, on conventional and high-speed generating unit, also for hybrid and electrical vehicles. On power supply, both in on-grid and off-grid operating connection. And for what concerns the mobility, on charging station and in particular on onboard generating units. So sorry, I'm going faster. Okay, we have many projects in collaboration also with companies. So we have many industrial companies that found projects. Mainly the research and development to companies concerned the full converter design and the full design of the control board from simulation to the real implementation, also including hardware in the loop simulators and customized control board. In this recent year, the increasing complexity of the converter is requiring, of course, also for more complex control board based, for example, on FPGA and combined use of FPGA and DSP. So Sorry, I have deleted some slides that appears. From what concerns teaching activity, we organize every July a summer course on power electronics and its application. 1 week is devoted to lectures, to seminars taken by academic and industry partners such as National Instruments, Huawei, Semicon, or Infineon, for example. And one week of on end class taken on a specific power electronic board based on the National Instruments SOM. So in particular, I'll show just some example of collaboration with industry. We have developed a specific control board based on the National Instruments SOM that is provided with, it's powered by mainly a zinc FPGA together with a DSP. And we are elaborating different documents to introduce the graphical programming for power electronics. So we have developed a specific control board to enable graphical programming, basically with Labio FPGA, specifically developed for complex control structure, complex converters in power electronics. So this is our recent collaboration with National Instrument Corporation, USA. So yes, in this slide you can see the control board developed by us, based on the National Instruments SOM, that we win the first prize last year at NI Days in Italy. This is very useful when you have to control a lot of switches. For example, we can command up to 70 power switches. We have Ethernet connection, so we have the possibility to interface this control board also with in real time with an host PC. Okay, this is the application of this control board, for example, to a 3-phase 4-leg voltage source inverter. If you want more information, you can find more documentation on the website padbook.com, and you can find also some example in Labio FPGA, some template in Labio FPGA. Another recent contract is with Infineon to develop a full-SiC inverter for driving the electrical motor drives and evaluate the effect of this new technology in conjunction to the electrical drives. And so you can see in the picture the full-SiC inverter that is based on a new Semicon mini skip model here. This is very, very small. So we can obtain in this case a very large power density. So this is another research contract is with ABB. It is related to a capacitor charge that is used for high voltage switches in the network. I skip some slides because otherwise we get too long to discuss. Okay, this is a unidirectional T-rectifier that was developed for Huawei. We are developing a very high efficiency UPS for Huawei. The target efficiency will be 97.5%. We developed a custom power module, integrated power module for
developed by Semicron. So we are obtaining very good results with this configuration using T-rectifier structures. Okay, for control system point of view, we have developed many control architecture for four-leg voltage source inverter, in particular multi-resonant controllers, repetitive controllers, model predictive, and we have obtained in this case very, very low distortion using the pedboard and of course the rest of the converter. We obtain a near zero THD in this case in the output. Okay, I'll skip some. For what concerns the solid state transformer, you know that the developing of the future electricity grid will need an energy router, so we have to develop a reliable and efficient solid state transformer to permit the power flow to be exchanged in the network. So in this case, we have recently released the new topology for a solid state transformer, and basically based on a proper connection of these different indirect matrix converter and permit to obtain there are no DC link capacitors in this configuration. We are in the very first experimentations, and basically I can conclude. Okay, just the last one is an application for a hybrid in automotive, and is related to the turbo expander coupled electrical drives to recover energy for the exhausted gas from turbines. So in this case, we have used a very high-speed electrical drive in range of 12,018 revolutions per minute machine. It is very high performance. A very high performance inverter has to be connected in this case because of the fundamental frequency that has been set to 1.2 kilohertz. So very fast power electronic converter is needed in this case. I'll skip some. Finally, this is very another application that has been developed some years ago, and is related with an hybrid electric and diesel electric vehicle, and in particular to the powertrain of these vehicles. Okay, so I conclude just to then we can share, of course, the presentation with Professor Caldarelli. So these are the main collaboration of our research center with respect to with companies and other research center in the world. Thank you very much for attending this presentation. If you have any question or any comment,
Yes. Could you please tell that hybrid truck you have shown, was it parallel or series configuration?
or might need to be closed.
Okay. Sorry. We have disabled the mic for a mistake.
It's parallel and series.
Has two configurations. One is in parallel, one is in series. So in one case we have just the diesel generator charging the battery, and another case is in parallel. But anyway, if you want more information, I can give you by mail. Can you hear me? Yeah, of course.
E poi le mando tutte come chiocciola latte, ce l'hanno in realtà perché stanno caricando tutti i soldi.
Okay, of course we share also the slides, so
Ce l'hai nemmeno.
we can get in touch later if you like. Uno ce lo siamo persi.
Okay.
No, è tornato.
I will send you the list of the emails of all the presenters from Tor Vergata site.
Okay. I have class now, I'm sorry. So I thank you for attending. Okay. Have a nice day.
Who is the next speaker?
Here, Dennis.
Now, Professor here. One more from Rome. Professor, one more presentation from Rome. Or to Professor Cardinelli.
Yeah, just a moment. I have the dean of the faculty that is now ready to present our faculty of engineering. Okay? Okay?
Yes, sir.
Che parla, mamma mia. Scritto, ma no. Sono di matti. Peccato che è morto tutto. Se il problema lo facciamo così. Cosa faccio in pratica? Perché guarda, questo è precaricato, capito? C'è un po' un casino. Sari, could you upload the presentation of the dean? I will send it just now.
I will send it just now. Yes. Sir, the presentation had been uploaded.
Did you receive?
Now I received once more.
The name of the file is
Yes. Please give
Engineering School
20 seconds.
presentazione. Okay.
Sì, ha fatto
Presentazione dipto. This presentation exists.
Okay, sorry,
No. Did you receive the presentation? Engineering School?
Yes, and uploaded. Please. There are 2 pages and documents.
Okay. Non vedo, ah no, c'è 2, aspetta, 2. No.
Микрофон работает.
I don't see the. Is the upload over? Or? I don't see the file.
Just 1 second. I have uploaded. I will check it out.
Yeah. I don't see the file.
Sir, the file is too big. Could you use the screen sharing for presentation?
Sorry?
Ok. Allora devo distaccarlo da qui. Prendo e lo stacco prima perché adesso non c'è abbastanza. Sperando che ci sia questo attento, no? Non te la metà. Ok, devo fare uno share. Devo fare lo share dello screen, magari cosa vai, no?
Conosco anche poco la Windows. Sì, no?
Sure, I will do it. The file has been successfully uploaded. Please
Okay.
check it in the documents.
Okay, I start with the ecco. Okay. Ah no. Now it is a processing for me. I see processing. Così tanto. Okay, we are ready. We start with the presentation. Okay. Okay. Please, Joanne. Ma è molto pesante, no? Pesante, no? Ecco, ok. Quindi adesso
Good morning. My name is Giovanni Schiavon, and I'd just like to show you, to describe some characteristics of our School of Engineering. I've heard that something about the campus has already been described, so I'm not going into those preliminary details where we are in Rome, and just to say that this year we are in the 35th year from our foundation. So it's a quite young university, but we are in a network of YERUN, the so-called YERUN network of young European universities. These are the numbers, maybe they are already been listed. The campus, 600 hectares. It's a quite big campus. And okay, now we are in the engineering part. Our mission, we'd like to provide our students with tools to face the challenges that this rapidly changing society is offering them, and we would like to make them able to work on multidisciplinary profiles and to face edge problems in the edge fields. We have here some pictures of the building. Here is where we are now here. The classrooms, corridors. It's a quite big structures, about 5 years in this new classrooms building. And okay, other pictures, and this is the structure of our studies. It's the European organization. After high school, we have a bachelor, 3 years studies, then a master, 2 more years, and then the third level, 3 years for PhD programs. And also we have a specialization masters at the first 2 levels, and then we can exit to the job. The studies, the organization is based on the ETCS, European Credit Transfer Systems. We have 10 hours in the class and 15 hours for study, for student study per each credit. The bachelor is organized on 180 credits, while the masters are 120 more. And the courses are organized on 6, 9, or 12 credits each. We have courses on 2 semesters from October to January, then 6 weeks for exams, then the second semester until June, then exams, and then one other section of exams in September. We have we have a substantially two-year basis. The first 2 years we have the basic courses in mathematics, physics, chemistry, and so on, and then just to focus on the methodology of the engineering studies, and then we go to the specific courses for the specific applications. Here is the list. We have 10 bachelor courses on about all the classical engineering fields. You can see here civil, construction, computer science, electronic, and so on. And these are taught in Italian, but the last one, engineering science is totally taught in English. So it's a 3-year course where Italian and foreign students can apply. Then we have this one, the first one, construction and architectural, which is a 5-year course, which gives a double degree, an engineer and architect degree recognized on a European level. Then we have the master courses, which are again on about all the classical engineering fields and some innovative one. And 3 of these, you can see here, ICT and Internet, mechatronics, which is quite young, starting this year, and Professor Cardarilli is the coordinator of this one. And the last, chemistry for nanoengineering, which are these 3 totally taught in English. So again, for foreign students are what they need. And then we have 6 PhD level courses, again different fields, spanning from computer science and information to the industrial, classical, and electronic, civil, and management. This is the organization of the bachelor degree in English. We have the first 2 years common with the basis courses, and then we have the last one, which has a characterization in the different fields, which give the students their trail to the master courses that they are going to choose. Okay, this is quite general on the engineering science courses. And just to conclude, I'd like to say that our students are encouraged to not to study only classical topics, but also to put in practice what they learn. We have a racing team which is totally managed by them. They design and then construct a car which is used in competition with other same formula with international student teams. On the other side, we have another example of competition of students which combine the construction part of the buildings and the energy management of the same. And also in this case, they have been engaged in international competition with other students. We have programs of orientation and tutoring of all the students. Here we have alumni association where they are encouraged to meet each other. And this organization in particular, okay, the tutoring that I was mentioning before, all the students that help younger to go through their studies and practical with the secretaries and so on, and the Forum Università Lavoro, which is an annual big meeting where people from companies are invited here, and this is totally organized and managed by the students' organization, the student organization. And okay, we have a website where we have all these practical information listed, and these are some the website addresses.
Okay.
Okay. Thank you very much. This was that's it.
Do you have any question?
Thank you.
If possible, I propose to give to have the speech to Professor Di Natale, because he has a lecture and. Oh, yeah. Grazie, Giovanni.
Okay, good morning. My name is Corrado Di Natale. I'm a professor of electronics at the Department of Engineering Electronics. And I will give you today some information about my research group. I lead a sensors group in this university. It's a group, let's say, whose mission is to develop chemical sensors and biosensors. This group is shared with a colleague of mine that is working at the Department of Chemistry. So we have in the same group both electronic engineers and chemistry. So this gives us the possibility to control all the different aspects of chemical sensors. And here you can see the molecules that we choose as our, let's say, sensing material. This is called porphyrin. It's a molecule that is well known in biology. It's the same molecule that carries oxygen in the blood, or is used for catalytic reaction in the mitochondria. And we synthesize different kinds of porphyrins and use these molecules with different kinds of transducers. Here you can see some example, field effect transistors, quartz microbalances, or the measure of conductivity, or the optical properties. And here you, oh sorry. Yes, now it's coming. Okay, here you may see some different kinds of sensors. All these sensors are based, let's say, on the use of this sensing material, but applied to different devices and in combination with different materials. For instance, here you see, let's say, the use of metal oxide semiconductor nanostructures. They are functionalized with organic layer, with the porphyrin layer, and then they are used for gas sensing. Or you can see here carbon nanotubes, again functionalized with porphyrin or field effect transistors. But the most advanced sensors that we are developing are quartz microbalance coated by porphyrins, and we do with these sensors an electronic nose. An electronic nose is an ensemble of different sensors, so of wide selectivity, and it can be used, let's say, to classify, to identify different complex compounds. And in the years, we used these sensors in different applications. This is, let's say, the device that is currently designed and produced in our group. The sensor is a quartz microbalance, is a quartz crystal, and the resonance frequency of these crystals is depends on the amount of mass gravitating onto the surface. This red spot that you see here is the porphyrin layer, and when volatile compounds are absorbed, the porphyrin layer changes its mass, and then we have, let's say, a variation of frequency. In the current electronic nose, we have 12 sensors, and all the electronics necessary to read the resonance frequencies of this sensor. And at the end of the story, we have an instrument that can work autonomously, and we have now different instruments installed in the world. We have some of them working in Paris or in Botswana, in Italy, in different locations, and in Europe too. And among the applications that we developed with these sensors, there are basically three different kinds of application. The first one is the use of this sensor for food control, food quality, and food, let's say, and food spoilage, or food characteristics, and so on. This is very interesting because it gives the opportunity to compare the electronic nose with the natural, with the olfaction, with the human olfaction. Another important application field is the medical diagnosis. We are using this sensor since the beginning of the 90s to measure the volatile compounds released by the human bodies. In 2003, we made the first paper showing that it is possible to diagnose lung cancer, measuring, let's say, the volatile compounds in breath with these sensors. And along the years, we use these sensors in a number of different, let's say, medical applications, and even to control cultured cells or microorganisms. The third great application is the environmental control, and here you can see a couple of applications of these electronic nodes in the International Space Stations. We made two, let's say, space missions and developed the instrument to work inside the space, inside the spacecraft, and it has been demonstrated that it can work, let's say, in space. It can also, let's say, bear the stress of the launch of the spacecraft. Here I add some details about, let's say, the medical applications, and this is not. There is, let's say, a quite number of studies that demonstrate that different pathologies alter the composition of the volatile compounds that are released by the body, in particular in the breath. And you can see the lung cancer application, and we can make very simple measurements, just measuring the breath of patients. Recent applications were, let's say, dedicated to studies the relationship between different pathologies. Here you see malaria, and we just measure the changes of volatile compounds when in mice when they are, let's say, infected with the malaria parasite. The central image is about a study about tuberculosis, and this is a project with the University of Botswana in Africa, and they just operated the instrument in a local hospital, and we got interesting results about the possibility to diagnose the tuberculosis, but not only diagnose, but also to follow the prognosis, so the process of the effect of therapies. And finally, the discrimination of different stem cells. Stem cells are very important for therapies now. There are therapies based on the implantation of stem cells, but it is important that when stem cells are implanted, they are totally differentiated in order to avoid differentiation that can give rise to special kind of tumors. So in these studies, we've shown that different non-differentiated cells have a completely different volatile compound profile, and this can be detected by sensors. And another application is about another kind of sensor that may be of interest is the sensors for liquid environments. And here we develop, let's say, both electrochemical sensors and optical sensors. And here I just added a couple of examples of the use of electrochemical sensors to detect the disease from urines, and the detection of contaminants in water using optical sensors. This was done in a European project that recently ended. And another couple of examples of the activities that are carried out in my group is about, let's say, the interpretation of cell movements in organ-on-chip systems. This is a very interesting aspect as very interesting support for medical diagnosis and for therapies. So instead of studying cells in vivo, it is possible to grow species of organs on chip, and then to follow the behavior of cells when they undergo a therapy. And in particular, the mobility of cells is observed, so we need, let's say, special video analysis for them, and this is something that we are currently pursuing. And finally, data analysis is an important issue for our sensors, and then we are continuously developing algorithms for high-dimensional data analysis. And these algorithms are applied not only to sensors, but even to behavior, let's say, to determine the behavior of people, the emotional state, the emotional status of people. And we take a lot of inspiration from biology, let's say, from how the sensorial signals are processed in biology. So I just gave you a very quick, let's say, overview of the activities in my group. Here you can see let's say the website of my group. You can connect them there, and you can get, let's say, more detailed information about what we are currently doing. And if you have any question, I will be happy to answer you. Thank you.
Okay. Any questions?
Thank you very much. It's incredible.
That was just unbelievable.
Any questions from the floor? On electronic side?
All right. Thank you for your attention. You can refer to the website if you want to get more information. Thank you.
Thank you. Can we have a speaker from VIT University? Okay. We'll have Professor Matthew Noel presenting the next one. Professor, in November, your PPT is open. Okay. And then I'll share the slide. Okay. Sure, sir. Okay. Yes, that's all. Yeah, greetings from VIT University. Can you hear me? Yeah, I'm Matthew Noel. I'm a professor at the School of Electrical Engineering. My presentation will be on machine learning and nonlinear control. So, okay. Yeah. Professor, please slow down a bit. So, I will be presenting some of my research on machine learning and control. Now, in recent years, new ideas in machine learning has enabled the solution of difficult problems in nonlinear, underactuated, constrained, and high-dimensional control problems. Okay, so this is due to some of the factors are advances in computing technology, hardware and software, especially GPUs, and better programming technology and algorithms. Okay. So algorithmic advances have been in the fields of supervised learning, reinforcement learning, and we have done some work combining reinforcement learning and supervised learning paradigms. Okay. To start with a brief introduction. Okay. Suppose. Okay. So one of the drivers behind machine learning is this concept of vectorized programming, which we found useful in our research. So suppose we need to take the dot product of two matrices A and B. Okay. So traditionally we would need a for loop in a conventional programming language like C or Java. But in a vectorized programming language like MATLAB, or if we use Python and numerical Python library, we might concisely express it as, in the example that I just provided, you could just stretch out this A into a column vector and just do a single matrix multiplication. Okay. So in this way, what really happens is that the for loop gets pushed to the compile layer of the code, which enables the code to run much faster. Okay. So I will present a series of increasingly complex examples of applying new ideas in machine learning to control problems. Okay. Just a brief overview of machine learning. In a conventional programming paradigm, we might think of a program as a function which maps inputs to outputs. Now, in the machine learning paradigm, we collect a huge number of inputs and outputs and try to infer the function itself, which maps the inputs to outputs. Now, one point note is that this function can be quite complex. For example, we might think of, in an autonomous robot, in an autonomous navigation application, for example, the input might be an image from a dashboard camera, and the output might be the angle of the steering wheel. So even if you have a 28 by 28 pixel image, we have 784 inputs, and so the function which maps the dashboard image to the control action, which is the angle of the steering wheel, is a very complicated function. So the question is, how can we learn this function from data? So the primary, the principal idea behind machine learning is that, if we have a lot of data, we can get intelligence from the data. And a machine learning algorithm is not limited by the intelligence of the programmer, but it is limited instead by the training data. So this allows a machine learning program to be more intelligent than the programmer. Okay. So another view of machine learning is, we might we might view machine learning as an agent interacting with the environment. So the agent can take actions, and the environment in turn provides feedback in the form of rewards and state transitions. So the ultimate goal is for the agent to learn a mapping between states and actions, so which we refer to as a control policy. So the ultimate goal is to find the best action or the optimal action to take in each state. So the ultimate goal is to learn this function or control policy which maps states to actions indirectly by receiving rewards from the environment. So reinforcement learning solves the general problem of how an agent can interact with the environment and learn to solve a problem or achieve a goal through indirect rewards. Okay. So another development in recent years is this idea of deep learning, which has increased the application of machine learning to different to a wide variety of engineering fields. So in classical machine learning, you have inputs, and we manually define features, and the mapping between these manual features and outputs is learned by the machine learning algorithm. The difference with deep learning is that we learn the features and the mapping. So there is no intermediate stage where we need to manually define features. So we might refer to as the data-driven approach. Now we have taken ideas from machine learning and applied them to difficult control problems. So this is one of the earliest problems that we worked on. So suppose we have a boost converter control problem. Suppose our goal is to measure the current in this inductor and the voltage across the capacitor, the state variables of this system, and use that information to control the load voltage. So the control action will be the duty cycle to the MOSFET switch here, and the goal is to achieve a certain desired voltage across the load. Now this problem is complex because the system is nonlinear because of this MOSFET switch here. Okay. So we might view this control as as a series of states, actions, and state transitions. So imagine that we start at some initial state S0. We take an action A0, and this causes the system to transition to state S1. So next we take an action A1 in S1, which leads us to a new state S2 in which we take an action A2. Now the goal is, so the idea is, how do we decide the best action to take in each state? Now if we can figure that out, then we can control the system, because ultimately control, the entire control problem is just a problem of function approximation. That is, learning a mapping between the state of the system and the optimal action that needs to be taken. Now, one of the surprising ideas in reinforcement learning is that we can take these optimal actions with just the knowledge of a scalar function which specifies the desirability of each state. Okay. So we might define a function v of x for each state, which summarizes the total rewards that we can expect to accumulate from that state if we follow a certain policy. So the goal is to find a policy which maximizes v of x for every state. So how do we? So the question is, how do we frame this reward function? We could for this problem, one of the reward functions that we tried was this. It is just negative some constant times absolute value of the desired voltage minus the voltage at a particular state. So the reward will always be negative unless the current voltage happens to be equal to the desired voltage. Now this was the final control policy that was learned by a reinforcement learning algorithm which was applied to this problem. Now, one problem is that the state of the system is continuous. So we have to discretize the states. Both the inductor current and the capacitor voltage has to be discretized. So we might discretize x1, the first state, inductor current, to some n1 levels, and we might discretize the second state to some n2 levels. Of course, because of this discretization, we lose some fidelity. So in order to compensate for that, we use reinforcement learning to learn a value function for these discretized states, and then we use a neural net to predict what the value function will be for intermediate states. So we use supervised learning in synergy with reinforcement learning in this application. So we were able to design a controller for this nonlinear system which could outperform the state-of-the-art controllers from literature. So this is an example of a control policy that was learned from training data alone. Okay. Another nonlinear system which comes up frequently in process control. This is a nonlinear regulation problem. Imagine we have a 2-tank or an n-tank system, and we need to regulate the height in one of the tanks. Now this system is nonlinear because of this of the square root function that we encounter here. And also this function cannot be linearized near at h equal to 0. So at h equal to 0 it has a non-linearizable nonlinearity there. So this system, so the question is, how can we design a controller without linearizing the state equations? Okay. So if we want to achieve large changes in the state variable, then we can't use a linearized strategy here. So question is, how can we do that? So again, the way we solved it was by discretizing both states H1, H2, using a reinforcement learning approach to learn a control policy, and use a neural net to learn the control to predict the control action for intermediate states. Okay. So what I'm showing you in the bottom is an example of a reinforcement algorithm acting in concert with the neural net to solve this nonlinear regulation problem. Okay. So this is another application that we worked on. So imagine that that we need to design a controller for a robot to move smoothly over a track. In a conventional approach, we might solve that using two sensors and a bunch of if-then rules, which specifies what action has to be taken in each state. Now we solve this problem first by using a neural net to learn the mapping between the image of the track and control action. Then we improve that further by using the control policy learned by neural net to use the control policy learned by neural net as an initial approximation, which is then refined using a reinforcement learning approach. Okay. So this is another problem that we worked on. Now, suppose we have a high-dimensional nonlinear system with constraints as well. So I'm just giving you a two-dimensional example so that we can visualize this. We might think about the state or configuration space of the system. We might think about going from some initial state given by this blue dot to this final state represented by this orange dot, while avoiding some forbidden states. So due to constraints, maybe due to actuator or state variable constraints, we can't, let us say we can't go to that set in the configuration space. Now question is, what sequence of control actions will take us from the start state to the end state? Now one solution is to use RRTs, rapidly exploring random trees. So what happens? So the problem with conventional RRTs is that if you have a narrow channel in the configuration space, then it is very difficult to find a path through the narrow channel. Now we were able to change the probability distribution of sampling, and we were able to modify the basic RRT algorithm to find a path through this narrow channel. Okay. So essentially, if you have a high dimensional problem like this, let's say you have this high dimensional coupled liquid level system. So where n is like 100 or 50. So I'm showing you the results for a 50 tank system. So we have 50 coupled tanks, and we have constraints on state variables and flow rates. Now the question is, how do you take this nonlinear system from some initial state to some final state? How do we design a sequence of control actions that will do that? Okay. So we were able to solve this problem with a modification of this path planning problem, path planning algorithm, which is usually used to solve problems in robotics. We took that and we modified that, and we applied applied it to the control of this high dimensional system. Thank you for listening. Any questions?
Leader will come back.
Thank you very much. Ukrainians still have no questions up to now, but we will be very appreciated if you will share your presentation.
They are asking for sharing this presentation.
Yeah.
Any questions?
Thank you for patient listening. Can we have another speaker from VIT following? Yes, wonderful. Professor Dennis, yeah. Professor Dennis will be presenting now.
Good afternoon, professors. I'm representing mechatronics research group at VIT University, and I'm going to brief about some of the ongoing projects in our research group. And we have different areas in our mechatronics research group: modeling and simulation of mechatronic systems, and advanced control and feedback algorithms, condition monitoring systems, programmable automation. So in all areas we have different colleagues. They will be presenting you these areas. And I'll be focusing on some of the research works which are ongoing in instrumentation lab. We have a signal processing system and PC based image acquisition systems and mobile DAC systems. Using this, we are working on some of the research projects, and we also have PLC and SCADA and some of the softwares: MATLAB, Simulink, Automation Studio, PicoSoft, and Adams. And we also have in our school advanced material processing and Center for Advanced Material Processing and Testing. We have hydraulic presses, EDM, wire cut EDM, CNC milling machines. And we also have an automotive research center. We have a computerized engine testing facilities, emission testing facility, and data acquisition systems. And some of the project work which we are doing are the vision system for spindle radial error measurements. So we are using high-speed camera for measuring dynamic movements in the machine tools, which is the funded project from DST. And through this we have established a vision system using a high-speed camera and ring lighting systems. And recently we have purchased a line scan camera for taking images of high-speed moving conveyor lines. And this is the testing we have done in the machine tools to take.
They could not share the screen. Nothing we can do. They are to
I think not share.
Can you start?
Yes.
இல்ல உஸ்மா கேட்கறதுல அந்த மாதிரி கேட்கறாங்க எதுக்கு டிஸ்கரேஜ் ஆகுது முதல்ல ஆரம்பிங்க போட்டோ வச்சுட்டு நான் கட்டி பண்ணிக்கிறேன்.
So this is the recent project which we have completed at our mechatronics research group, which is related to the machine development, and this is for testing the spindles in the machine tools, and we have established this machine system using this high speed camera and ring lighting systems, light measurement using lux meter, and we have also purchased the line scan camera for a more high speed imaging in the conveyor belts. And this is the testing arrangement in machine tools, where we will capture these images and we will further process in the PCs for measuring the dynamic movements. And we use algorithms in OpenCV and MATLAB for detecting these edges, and then we will measure the dynamic displacements. And subsequently we have also completed project on controlling the electrical appliances using mobile phones and the egg vending machines. Further, we also work on automation the sieving process using the robotic systems. And these are all the slides which are related to automotive systems, to develop virtual reality based haptic force feedback for steer-by-wire automotive applications, advanced stability control algorithms, and developing human powered vehicles and hybrid vehicles. And we also work on ergonomic analysis, and these are recent publications. So we look forward collaborations in these areas. Thank you very much.
Any questions? We have 4 speakers from National Mining University. Then we'll have another 4 speakers.
But we have dinner as well.
Yeah.
We have dinner as well. That's the most important schedule of this conference.
Professors, can you hear us still? Are we audible?
Yes.
Okay. So we'll go for 2 speakers from National Mining University, and then we'll have a couple of speakers from India. Is that okay, Professor? Okay. Over to Professor Seri, National Mining University. National Mining University.
Dear friends, I am Alexander Balakonsev from the Mining University, Ukraine. My presentation is very short, very brief, and covers only one topic, only electric mobility in Ukraine. Well, this is our department. The department is small too. We have 12 members. Annually we graduate 45 students, and some years ago we have graduated 2,000 engineers. We also provide education in English of basic subjects. The specialty is electric power engineering, electrical engineering, and electromechanics. Particularly in our department, we deliver education in 2 specializations: automated electromechanical systems and electric drives, and newly opened specialization, programmable mechatronic systems and robotics. These are our research areas. We deal with energy efficiency, power electronics. We develop special control systems and design special electric motors for various purposes. And currently, the most hot topic is electric vehicles, and particularly the questions of their interaction with electric grids. I would like to draw your attention to a unique situation with energy carriers in Ukraine. Simply speaking, we have a very cheap natural, we have very expensive gasoline and natural gas, and electricity is cheap. It is because our energy system was built for heavy industry, metallurgical and mining enterprises, which are now in decline. So we cannot use the full capacity of electric utilities. That is why driving on electricity in Ukraine is very cheap. 8-to-1 ratio. You pay 1/8 of the price for driving on electricity than you pay for driving on gasoline. Our government does not promote electric mobility, it promotes it by itself. By all possible means, people buy electric vehicles for their own. Yes, it is a hot topic all around the world, and the world market grows, but Ukraine is among the countries of the highest market growth rates, and our market demonstrates a very substantial drop of sales of conventional cars. Perhaps that is why the most popular vehicle, electric vehicle in Ukraine, is one of the cheapest, Nissan Leaf, which constitutes nearly 90% of all electric vehicles on Ukrainian market. So these are mainly unofficially imported vehicles from the United States and Europe. Well, as you can see, just a couple of years ago, we barely had any charging station for electric vehicles, as you can see on the map to your left. By 2017, we have already plenty of slow charging stations and even starting to develop fast charging stations in Ukraine. That is the most discussed topic around the world, so-called range anxiety, the fear of running out of charge before you drive to the nearest charging station. There are 2 components in this topic. One is electric grids, the other is electric vehicles. We deal with both. So regarding the electric vehicles themselves, we focus our research on onboard electric equipment, electric powertrain, the galvanic battery. Lithium-ion battery is the weakest element of the powertrain. So we develop a solution for parallel operation of galvanic battery with supercapacitor. To do that, we are developing a DC-DC converter. It has controlled circuits for battery charge and discharge, while the ultracapacitor is attached in parallel to the traction inverter. The ultracapacitor will allow to capture more braking energy, and it saves battery life by smoothing surge currents from the battery. We have conducted simulation and established and estimated the optimal ratio of capacities of the battery and the supercapacitor, depending on the desired charge ratio of the battery. So as for the electric grids, we are preparing them for wider penetration of electric vehicles. We deal with optimal deployment of charging stations, apply a special mathematical algorithm to estimate the optimal location of slow and fast charging station around the city. And we are about to use so-called V2G technologies, vehicle to grid. Electric vehicles remain parked more than 80% of the operation time, so the capacity of their batteries can be used to increase the load on electric networks during night times and level the surges during the peak load times. Their batteries can be used to generate energy to the electric grids. Well, I think that was it. I will be glad to answer your questions.
Gentlemen, any question? Sophie? Okay, if you don't have any questions so far, please let me invite our second speaker. Alessandro Besta, the researcher, postgraduate student from the same department, please.
Good day, dear colleagues. To your attention is a project on the topic of combined electromechanical converter for electric and hybrid vehicles. So first of all, the most important issues in the automotive world are fuel economy and environmental protection. That is why we need to find new solutions for vehicle manufacturers. Scientists from all over the world, in cooperation with automotive giants, have developed new systems for the automotive industry. The results of their efforts was hybrid and electric cars. The most common electric drive scheme includes an electric motor, a power storage, and finally a controller. Several elements such as a solar panel and a rechargeable battery can be used as an energy source. The scheme for counting the several energy sources consists of using a common DC bus. As seen on this slide, in addition to the DC-AC converter, which is used to control the AC motor, there is also a DC-DC converter. The presence of two converters complicates and entails a rise in price, or the cost of these systems. The idea of the new scheme is to combine sources of DC voltage which work on the consumer through a single converter. Was used a classical vector control, but with a special algorithm for switching the keys of this converter. With the lower switches on, the closed circuit to the EMF arises. After this, when switching the top level keys, the reactor is discharged through the reverse diode to the plus of power source. In the course of the experimental work, the oscillograms were obtained for the variation of the average of the current of the electric motor. Left picture shows the waveform before special algorithm, and the right pictures after special algorithm. As can be seen, the shape of the current does not change, but the average value of the current changes, which indicates the transfer of energy from one source to another. This diagram shows the dependence of the power of change when a special algorithm is connected. As can be seen, the total power increases, and this indicates the operability of this scheme and this algorithm. So that's all. Thank you for attention.
Dear colleagues, do you have any questions to our speaker? Dr. Jayaprakash.
Can you hear me?
Yes, yes. Do you have any questions to our speaker?
No questions from our side.
No questions
from our side.
We are ready to answer the questions from Tor Vergata.
Now you can hear me. Okay, very good. Thanks. So I'd like to present, just a single presentation because I think it's it's closer to possible areas of cooperation. It's describing some activities we have done on the hybrid power systems, and the application is, this project has been funded by the European Union, and there were some partners, but mainly this presentation was done by our university and Ericsson, the company providing equipment for telecom applications. Okay, this is the budget, not very interesting, and this is the solution instead. So we have photovoltaic panels in the range of a few kilowatts, providing power ultimately to a radio base station for cell phones. And so there is equipment here, and to integrate the renewables, we had a solution that was based on a battery, of course, but this was also including fuel cells and electrolyzer. And the main target of the project was the design of the solution and the realization of a number of different real sites. From the standpoint of the energy solution, we call it an islanded integrated system, islanded hybrid power system. So there were 11 sites, and okay, it's not very important for today.
Okay.
Okay. And these are the demo sites. We have tested them mostly for 1 year. They had different power on average, and they are located in Italy, and they were actually equipped with the real equipment of Italian providers. So we have 3 main providers in Italy, and we had radio base station of Telecom and H3G. So this is a typical layout of one of the sites. So there's a canopy with the photovoltaic modules on top, and here there's the fuel cell battery, and in some cases the electrolyzer solution. One of the problems was, of course, the legal authorization of the site, because there's hydrogen, there's compressed hydrogen, so this may be a little bit of a problem. Theoretically, you would think that with the electrolyzer you can cover all the energy need during the year. So, for example, whenever you starve of battery energy, you should utilize the hydrogen that is produced in the summer, theoretically, through the electrolyzer. But in fact, since the space at our disposal was very limited, and since the hydrogen needs to be compressed at low pressure, so 30 bar usually, so this turns eventually to be a very big problem from the standpoint of energy density mostly. So this was also, I mean, a little bit problematic in the project. This is another site. Here you can give a look at the antenna too, and the compressed hydrogen here. So there were bundles of 16 bottles of 200 bar hydrogen and all the other equipment. So we had 11 of this. Okay, this regards the market, and the ultimate outcome of the project was an evaluation of the total cost of ownership of the solution throughout the lifetime of these systems, which is in the range of 10 years. So what we have usually for hydrogen-based system is that the investment at the very beginning is high. And we compared it with a traditional solution for islanded system, which is a diesel genset. So it's you know, steadily just powering up the radio-based system with the fossil fuel, which of course is noisy and polluting at the same time. So it's something we want to avoid. Okay, then the solution, the diesel genset solution, which was a turnkey system, so it was just rented by the Italian providers, were very expensive, you know, as a flat rate for rent. And our solution instead was, you know, in the long run was cheaper. So we achieved our target in the project because we proved that the system is sustainable from the economic standpoint, and of course clean at the same time. We had 2 main solutions. So one was hydrogen compressed, and the other was methanol with a reformer working at a higher temperature. So this was very, very reliable solution, but the reformer, you know, has some drawbacks, mainly related to the efficiency, because you need to sustain it with surplus power. Okay, again on the costs. Again on the costs. So the technical challenge here was the control. So whenever you want to, in the simplest case, to give rules to each subsystem to better understand who should work and at what load to provide a continuous load to the system, which is of course the mandatory requirement overall, then this turns out to be the strategy, and this is very important to have an optimal behavior of the system. The simplest strategy we can define is based on rules. So on the left side, although it's not very clear, you have an abundance of power from the photovoltaics. And then little by little on the right, you have instead batteries, and so batteries is here, and hydrogen is the last one. It's the most expensive resource we have on board, and we want to use it to, I mean, as low as we can. So because it's very expensive. You know, like I said, there's hydrogen from the electrolyzer here, and there's hydrogen from compressed storage that is brought on site, you know, so with the trucks. So this is the most expensive fuel we have in the picture. Okay, so this is not important. We had data collecting for you know, number of for 1 year for all this sites, so we have real data. And we have published a paper which you refer to if you're interested in the topic, where we showed, you know, the main results of the project, and we have detailed, you know, the analysis to 6 of the 6 sites out of the 11 I told. And I wouldn't run into the details, but what you get usually in general from every site is profiles of current. The DC volt is pretty much maintained at 48, so it trips a little bit depending on the mode of operation. So it's a little greater whenever the system acts as a battery charger, and a little lower whenever you use the hydrogen from the fuel cells, or the battery is very low. And in principle, so you have different weather, which affects, of course, the system behavior. So if you have, for example, bad weather, a very cloudy day, you have power from the photovoltaic, which is very fluctuating. The load is almost constant, is the gray line, almost constant in the 3 cases. It fluctuates depending on the traffic, for example, the cell phones, which are, you know, connected to the station we're talking about. And the fuel cell is the red one. So whenever you have a bad weather day, the fuel cell acts and runs also during the day itself, which is missing whenever we have a good weather. And good weather and average weather share the fact that the fuel cell does not operate during the daytime, but in the average weather day, we have the fuel cell coming back at early at night. So this affects for consumptions and the economy of the system overall. And this, the rule-based strategy I was talking about was pretty simple. So this is what you see here, but we also developed, and it's not presented here in the presentation, more advanced strategies based on the model predictive control, demand response, interaction with the weather forecast to optimize the behavior of this system, to have different scenarios, for example, to maximize the profit if you think of a grid-connected system, microgrids, or to maximize the durability of the batteries, or to minimize the CO2 emissions. So these 3 features are what can be implemented in an energy management system supervisor. And other things are if you're interested, are reported in this paper I was talking about. You can write to me and I can send it the paper if you want. I write here again my email address. And what we thought was very important is to understand how to characterize dimensionless-wise the system, which is a very important task toward the design of such systems, in our opinion. So, just in a nutshell, if you oversize the photovoltaic module, this can't be the most optimal solution, because then you need to, you have a lot of abundance on power and then you waste a lot of power, so it's wasted money. On the other hand, if you downsize too much the system, this may affect the amount of compressed hydrogen you have to bring on site. These are pretty much the asymptotic, so the extreme cases. I think that was pretty much it. So thanks for your time, and I'm available, to talk a little more about this if you're interested, to send you papers, and however, my email address is there. Thanks very much. And if you have questions, of course, I'm available.
I see VIT is not online. I see VIT is not online.
Yes, I wrote to Jaya Prakash and asked him to push the speak button once more. They hadn't disappeared for some reason.
Could you speak louder?
Even on Skype. Maybe internet interruption or something else.
Could you speak louder?
I wrote to Jaya Prakash, I wrote to VIT, the message they have been disappeared. But maybe there are some troubles with connection, because even on Skype, Jaya Prakash doesn't answer.
Okay.
And we have a small question regarding your great presentation. Please, Alexander.
Could you please tell us about the hydrogen storage in that project?
Yeah.
What was the pressure you are storing hydrogen at, and is there any complications with that?
Okay, the pressure of hydrogen was in general 200 bar, but this is for hydrogen brought on site. So we consider it hydrogen produced from fossil fuels. Mostly it's produced from natural gas, reformed. Ideally, you would like instead to produce hydrogen on site from renewables. This is what we always talk about. But electrolyzers work at 30 bar. And if you compress hydrogen from 30 to 200 bar, then you're going to waste a lot of energy, so which is nonsense. So if you maintain some of the bottles at 30 bar to maximize your usage of renewables for integration through hydrogen, this at the end turns out into an unbelievable number of bottles you should place on site just to swap the energy from summer to the winter.
Have you calculated what is the energy necessary to produce 1 liter of hydrogen, or just one unit of hydrogen?
Every bottle is 50 liters, and with one bottle you cover few hours operation.
Okay, all right. Thank you.
Thank you. Thank you.
We developed some a prototype at our departments. It was a electric heater, and this heater uses not gas or oil, but uses the hydrogen and hydrogen. and we had an idea to use solar stations to dissociate water in order to burn the hydrogen into heater. But this is a prototype, and if you are interested in this, we will prepare background and description of the project, and we will send it to you.
Yeah, thank you. That would be very interesting. Of course, but that is for thermal power use or for electric power use?
Of course, but that is for thermal power use or for electric power use?
It is thermal power use, only for heating, of estate, of industrial enterprises, to heat during the winter times and to reduce the usage of fossil fuels.
Okay, so that is one solution. Of course, we consider hydrogen always as a precious, resource. So to me, burning hydrogen for thermal power is a little, problematic from the exergy standpoint.
For thermal power is a little, problematic from the exergy standpoint.
The biggest problem is to get from the gas the hydrogen, pure hydrogen, because in a mixture with oxygen it makes the very flammable gas, and that is the point that we should make some membranes to select only the hydrogen.
Mm-hmm. Yeah,
Thank you very much for your presentation. We will send our projects and ideas. Maybe it will be interesting for you and for some future project purposes.
Okay. Thank you very much. Bye.
Still we don't have the video conference. Still we don't have a video conferencing with VAT. Would you like to allow us to start our presentation of our scientist?
I don't know how long will be the absence of VIP. Could you contact them?
Yes, I contacted VAT, but I don't receive the answer. I wrote to Jayaprakash, Dr. Jayaprakash. He is available on Skype, but not available in webinar, on phone, or somewhere else. Let me send him SMS. Occasionally he will answer. VAT has been connected.
We can go ahead with the Professor Marino. Sorry, Professor Marino and Professor Verrelli. Verrelli will be the speaker. Okay. Per andare avanti, sì. Poi quando magari ti rispondono loro, okay. So, my presentation concerns the research activities which are carried out by the Automation and Control Group, which is composed by two full professors, Professor Marino and Tomei, two associate professors, Professor Santos Rossa and Professor Verrelli, and Marco Di Berti, who is the technician
who gives the technical support in the lab activities. So we have 4 research activities, main research activities. The first one is about the control of electric vehicles. The second one concerns biomedical applications. The third one, robot control, and the fourth one concerns the control of electric motors. So the first one and the fourth one are apparently connected. So I will skip the technical details and I will present the main results, the most recent results that we obtained in the 4 areas. The common feature of all the scenarios is the presence of systems which are highly uncertain. We have the presence of structured uncertainties or even unstructured uncertainties. So the first contribution that I describe is a space learning control for autonomous vehicles, in which the autonomous vehicles has to learn the path on the ground, which is a repetitive path, without knowing in advance the curvature of the path on the ground. The vehicle has the availability of only the signals coming from the camera. So the learning control is a learning control which is theoretically developed in the space and not in the time, which is because the periodicity is only in the space. And theoretical results lead to those figures, the figures that you see in the bottom of the slide. In the first trial, we have an error in learning the path, while in the last trial, we have the perfect learning of the path. The second result that I present is the cruise control for electric vehicles under sleep constraints. We have no video here, but I will describe the application with reference to vehicles with in-wheel motors. We have two in-wheel motors directly connected to the rear wheels. This is a description of our experimental scenario. We have 2 control inputs, since we have 2 in-wheel motors, so we have the possibility of controlling the speed, the longitudinal speed of the vehicle. This is known as cruise control, and simultaneously we can control the yaw rate. And the problem is that we have a change in the external conditions. For instance, we have the artificial presence of soap on the ground, and the cruise control has to be able to automatically decrease the reference for the speed, for the longitudinal speed, and at the same time to reduce the yaw rate reference, so that we have operation at safe slips, longitudinal slips. The theory is based on the use of the contraction mapping theorem, and here in this figure you can see that the reference for the longitudinal speed is reduced as soon as the vehicle moves on the ground with soap, and the same for the yaw rate. So stability is preserved, and the control algorithm is automatically able to reduce the speed. And the same for motors with vehicles with centralized motors. So this is another application. This is in collaboration with the Research Institute San Raffaele La Pisana. And we have a patent proposal with them. We have the control of the heart rate of a subject performing exercises on treadmill or cyclometers. We have 2 control schemes. The inner control scheme, which is responsible of the heart rate control given a reference, and the supervisor control, which is able to impose a reference which is suitable to the subject. And in this presentation, I will present results concerning the heart rate control. We have designed a global learning control, which is able to impose a variable speed in the treadmill. You see the figures at the bottom. In order to impose an heart rate which follows the reference. So we have two different subjects here, subject A and subject B, and the blue line and the red line describe the heart rate of the subject, and the dashed line describes the reference. So we have a good tracking performance even without knowing the subject performing the exercise. Another area is the experimental identification of subjects with chronic heart failure, because these controls for the heart rate are designed for subjects, for patients with chronic heart failure, in which the heart rate reference is important to be imposed in order to have a safe operation. On the left, you can see the experimental response in the heart rate of chronic heart failure patients. On the right, the output of the nonlinear model, dynamic model, reproducing the profile. So we have very interesting results in this application. And the last one, again, is a video that I will skip this video, but this is all a presentation of the results on the saccharometers, which are similar to the ones that were seen for the treadmills. The third area will concern the robot control. The dynamics of the control is highly uncertain. We have to use repetitive learning control by Padea approximants with theoretical foundations about them, and we used increasing order Padea approximants. In the first figure, you see the performance guaranteed by a classical PID control, while in the second, third, and fourth ones, you can see the performance achieved by the repetitive learning control with increasing order by the approximants. So the performance is greatly improved, and the results on the tracking performance are very satisfactory. This is the image of the planner robot that we used in the experiments. This is done in collaboration with the university, Second University of Naples, and the experiments have been carried out there. We have another important application, again a video which is skipped, and this application concerns the synchronization of a robot with an external signal which is periodic, and we only measure the external reference at the runtime without knowing the period of this reference. So the control must be able to estimate the period and then implement a repetitive learning control, so that we have perfect synchronization with external signals. The last area concerns the most recent results on the electric model control.